So our next speaker is Alan Wu from Smooth and Sharp, and he will entertain us with his talk on. At first I thought it was as abstract, but on how far can an RFID antenna reach biodegradability by using additive manufacturing, the creation of a worldwide first and the only ISO certified RFID antenna. Thank you so much.
Yes, thank you. Welcome, everyone. First, I would like to appreciate your time. Next 20 minutes you share with me. So in return, I will give you our successful development of this biodegradable RFID antenna. So first, I want to introduce SNS, where we are come from, what we are doing now, what we achieved, and what we can do for everyone. So we are in this business since almost 2 decades, smart car business, and we start to develop this DOP, direct on paper RFID antenna since 2015. And then 2020, we grant this ISO certificate for biodegradability. And this is our capability. So actually, we start from prototyping to mass production. And the production-oriented product development is very important, especially for commercial projects. So when we start to design something, we need to guarantee the production unit cost has to be acceptable by the market. So this is our strength. So that is the product roadmap. We can start for more components. Up to date, a small, tiny NFC antenna, we can power up to 7 LEDs plus 1 NFC chip. And then multiple layer. This is cooperation with EM Microelectronics. This is a chip, dual interface. So our antenna has to be push UHF and NFC antenna at the same time. And then different substrate. We start from paper, and the low temperature substrate like PET, we can also print it. And more complicated design, this is ECG, with more fine line, with more application. And then fine line. Today, we print row to row with gravure printing. The narrowest line gap is 150 micron and around 30 meters per minute. And depends on the customer requirement, we can do mechanical design. So, IoT, this term we know since decades, Internet of Things. So today I want to share everyone a new term, IoDT, Internet of Disposable Things. What is this? The IoDT is based on anything and everything else as long as it is produced cheaply enough to discard it. Cheaply enough, it's not from my pocket, it's not from your pocket, it's not from government budget. Sadly, it's at the cost of Mother Nature because it's so cheap. You just produce it, you just discard it. So we need to think about that. We are from the RFID business, so the RFID tech like this is the typical case in IoDT. RFID is a good product. People use it to optimize the supply chain. It means it will avoid material wasting in the food industry also. But there is a challenge. All this antenna is produced by chemical etching, and there is a tiny plastic inside after use. So I think in recent human history, the industrialization and automation is indispensable for civilization evolution. So that will be a challenge for me. How can we find an eco-solution, sustainable solution to produce this RFID antenna without chemical etching and plastic? It's a big challenge. So, always look on the bright side of life. Here's a number. Everybody happy because we are a commercial company. We are doing business. So that's very happy. RFID is growing. You can see these crazy numbers. 2026 there will be close to 90 billion tags like this. You will encounter this more and more in your daily life. People use this RFID for retailer business, optimize the inventory management and logistic management. So almost 30 billion IC is sold in 2021. And around 70% is used in apparel, footwear, and other retail business. Frankly speaking, all these application is disposable, just one-time use. And the cost of natural resources, because it's so cheap, so we can use it for a very short lifetime and discard it. Where have all the labels gone? Where? Okay, nobody discusses it. Here is the number, okay? You buy this and bring it home, and you cut it, and you dump it anywhere you want. What happened with these plastics, okay? So I made a calculation, because all these numbers can be quantified. First, if we're talking about 30 billion labels in 2023 this year, and that is a simple calculation, it's about 3.3 billion PET will be used. And if all this PET did not collect, it will go anywhere, so tiny. It will become microplastic everywhere and come back to you and me. And how, if we make a kilogram, it's not reality. If we make it in the area, it's about 45 kilometers of plastic waste. It's about the same area like here, Berlin New Coin, yeah? Okay, people tell me, oh, that is tiny. Compared to plastic waste today, that is only maybe 1 day or 2 days. But we are in this business. If we can do something just to avoid it, we need to do. And the second, less people talking about, I'm talking about this is etching antenna, etching process. You need pure water during this production. I take a number of this green printed circuit board. It means for 1 square meter of PCB, if you consume less than 230 liters, this is green production. So very easy calculation. If there is the 45 kilometers of plastics, unbelievable, you need to use more than 10 million tons of pure paper, or pure water, just to produce RFID antenna. And maybe for just 3 months or 6 months, and you just give it away. And another thing is you need to pray all these etched antenna in Far East. They don't damn their chemical soil and this polluted stuff properly. You need to pray. Okay. And so that's our challenge. So approach is very easy. A plastic is not good. So we try to make it on paper. And the process, we are in this printed electronic community. So additive manufacturing is only choice. So we are step into this challenge, and here's the conventional way to make this RFID antenna. Aluminum PET client through etching process, and you get the antenna. Our process is direct on paper process. From paper, direct to antenna. Here's the process. Okay, we developed this process by ourselves, and you can see, I have to say that it's more printed technology than really printed electronics, because the core of all process is actually graphic printing. So in this machine, we put inject, we have a screen printing, flexo and gravure, we use NIR and photonic. So this combination depends on the complexity of antenna design. We can run about 30 meters per minute with a 300 millimeter web. So a line like this, we can produce 1 billion antenna, UHF antenna per year on paper. Only 2 components. One is nano silver ink, the other one is paper. Slightly bigger like this tribute is enough to produce 1 billion antenna. And here is the key issue, why we can make this happen, is photonic. Photonic. The problem, when we face the problem, production speed and ink curing and sinter time, they are against each other, okay? You want to you want to reach a reasonable mass production speed, it has to be quickly. But you need time to cure. So that is a big challenge. And it means low speed that will cure and sinter will be better. But don't forget, our substrate is paper. If it run very slow, the process temperature, it could burn my paper. So that is a big challenge. And thanks for photonic, we get this problem done. Look, this is a snapshot. And today I talk it easy. Actually, we spent almost 8 years. Okay, there's some information behind the scenes. I still remember when 2016, first time we run the machine with paper and the conductive ink, all the paper like the morning toast, they're getting brown. And my team, they are so disappointed. And I cannot let my tear drop out of my eye because I'm the leader. So I need to throw out my tear into, and I say, okay, oh, it's still okay. It doesn't burn. We don't get fire. So we still have a chance to do it. And after that, we spent another 5 years. Today, we really can reach this process. So I have a booth there. You can go to see our beautiful RFID antenna with biodegradable certificate. So over the year, we spent more than 20 tons of different paper. Just try it. Try it with inkjet, try it with a different printing process. And we have a conductive ink. We use more than 100 kilogram inkjet, gravure, silver, flexo. And we spend more than 1 million RFID chip because when we print the antenna, we make the chip assembly immediately and we correct it. And that is the reason why we spend only 7 years to bring this product in the market. And up to date, accumulated, we already ship close to 50 million RFID label with this eco-friendly argument. And this is stock level scale that we can run a full-scale mass production, different antenna design, UHF, HF, and dual frequency. When we have this product and we go around the world, talk to the customer, and we say, okay, we print, it's eco-friendly. We use paper, it's eco-friendly. But at the end, after my meeting with my customer, I feel empty because it has to be some number, not just because I'm printing, I use paper, it's eco-friendly. No. So I'm thinking about, is there any standardization, is there any standard I can use to quantify my eco-friendly argument? After about 6 months, we sit together, talk to TUV Rhineline. At the end, he gave us this suggestion. Indeed, that is a certification for packaging. So he introduced us to use this EN 13432 certification. So I say, okay, let's go ahead. And we signed the contract. I still remember, after I signed the contract, I and my general manager, we feel empty because we are not sure. We are not sure whether we pass this or not. And actually, there are 4 pillars of this ISO certification. One is the chemical characteristic, is the heavy metal inside or toxic, and biodegradable capability and disintegration. And also the ecotoxicity. I will explain you in the detail later. Okay, here, if your BOM has toxic material, it cannot pass. If your material contains heavy metal, it can pass. So first, the TUB, he spent about 6 months to do all these tests. When it passed, we go to next step. This step is not laboratory test. The biodegradable test, he will put 30% of our material and 70% of the biomass. And it will put in a test condition for 180 days. The remain of my test object cannot exceed 10%. Our result is 95.2, so that is passed. After this certification, and then we go to so-called OECD 208, aquosity, so-called plant growth. Plant growth is very tough. So there will be a control group, 100% of soil, and again, our antenna with 70% biomass. And they will put seed, here's the soybean, put it together. And they will comparison, the growing, okay? After 21 days, the growing, if the seed in my test doesn't growing as good as the control group, that is fair. It can be happen, my plant, they're growing better than the control group, that is not okay, because it means maybe there is too many neutrons in my test object. And at the end, when it growing, get the flower, get the seed, and they will cut it and make the pure detail analyze. It means the plant, the seed, will contain no exactly the same like the control group. And after almost 1 year of this full process, and we get the certificate. And then we get the European composability for agriculture and for the industry. So we are the first one, up to date is the only one. And I encourage the people from this industry, maybe we can do it better. And here's a certificate. So for this RFID, we are the only one we can print this certificate number on that. And people, for example, in Europe, you can put this RFID label just into the current paper recycling circuit. So I see additive manufacturing is the beautiful thing. Look, only 2 components, paper and print, get what you want. So I think the beauty of additive manufacturing is you just put the natural resources at the place that you need. Thank you. Thank you. Yeah.
Thank you so much. So quick questions from the audience, maybe 1 or 2? Yes?
Thank you for the nice talk. I'm very interested in biodegradable and biocompatible materials. I have a question specific to the functionality of the RFID antenna. So after 18 days, was the antenna...
180.
180, was the antenna still working? Because for crops, for example, you want the electronics to last for the age of the crop, and then be biodegradable after the crop has been harvested.
Yeah.
So how do you relate the functionality, performance of the electronics until you want it, and then trigger the biocompatibility when you need it?
Yeah, very good question. So first I show, okay, this tiny antenna, and it can power 7 LEDs and 1 NFC chip with this tiny printed antenna. So my answer is, please do not misunderstand. This biodegradable, it means the antenna, the RFID label, have to be mixed up together with the biomass. My antenna, it doesn't disintegration when it not put in this biomass. So you can use just same as each antenna for 1 year to... Yes, yes. After, if you put into this so-called recycling bin, go into this waste paper recycling, it will go together with biomass. Yeah, yeah. But functionality is the same. Yeah.
Maybe there was another question over there?
Thank you. You had a lot of hurdles on the licensing and stuff like that, but you showed us this photonic process. How much would you say was this a key for your technology to work at the end of the day? So photonic curing, photonic soldering.
I think why we choose this technology, because we all know, I think we are all from printed electronics. If you have a conventional oven curing, when you bend it, your line will be cracked. It doesn't work. So that is the reason why the key point of our technology, one is raw to raw, and the second is the proper curing will provide a guarantee when we bend it, it doesn't break. This is the key technology we get from this process. Yeah.
Okay, let's thank our speaker again.
Thank you. Please come to my booth. Thank you.